Okay, this is a recapitulation lecture on sequencing. Or scheduling problems. So let's explain the problem first. Say suppose there are n jobs to be processed in two machines. Say n jobs. Let's take an example first. Let's take 7 jobs: J1, J2, J3, J4, J5, J6, J7, and they are to be processed in two machines, machine 1 and machine 2, and the operating time of the jobs in different machines are given. So let's take that as 8 and 5 for job 1, 6 and 3 for job 2, 10 and 7 for job 3, 11 and 12 for job 4, job 5 is 10 and 8, job 6 is 14 and 6, job 7 is 4 and 7. So suppose these are the activity time or the time required to complete the jobs in different machines. Like this particular example, if you take, that means if job 5, when it is processed in machine 1, it takes 10 units of time, and similarly for job 3, if it is processed in machine 2, it takes 7 units of time. So, and all the jobs are to be processed first in machine 1 and then in machine 2. Like in real life example, if you think about different jobs, say think about a shop where a cycle repairing shop or bike repairing shop. There some oiling and cleaning of the bikes are done. So first they have to be dismantled. Each part has to be dismantled, then cleaned, and then it has to be put together. So first part is dismantling different parts. So these are, say 8 bikes have come, 7 bikes, J1 to J7, all the different jobs that has to be done at the time, and these are the different times of dismantling the each part, and these are the second part. After it has been done and opened up, cleaned, then it is to be fitted again. So this part is opening up and this part is again to fit. So machine 1 means, say, first person who's doing the separating different parts and then cleaning, and second person is doing that again fitting that up. So this is where how the jobs are to be scheduled, so that the total time required is minimum. So the jobs are to be sequenced in such a way so that the total time of completing all the jobs is minimum. Also, it has to be looked in such a way that since for all the bikes or for all the jobs, the machine 1 will be working first, and then only all the jobs to be processed in machine 1 first, and then in machine 2, and then in machine 2. So it has to be, unless the job is completed in machine 1, it cannot be completed, it cannot be started in machine 2. That has to be remembered, and that is so that means unless a particular job is completed and machine 2 person is sitting idle, so here we have to minimize the idle time for the person who's working in machine 2, So the sequencing is done in such a way that the total time and total idle time also becomes minimum, and the total processing time will also become minimum. Now to sequence, there are certain rules of sequencing. So let's explain the rules first. Let's state the rules first, how to sequence, and then we will do the sequencing, and then we'll find out the total time to complete all the jobs. Now rule 1 Rule 1 is find the minimum time required to complete a job. If the minimum time appears in machine 1, that particular job is to be processed first, or we can say, or beginning of the queue. And rule 2, if the minimum time is appeared for machine 2, then that particular job will be processed last, or at the end of the queue. So this is the basic simple rule that we are that we will be remembering. So if a particular, first we will find out the, from all the times that are given, we will find out what is the minimum time that is there. So if we check, say if we check here, the minimum time is 3. We can see that the minimum time is 3. We will not look at the job or not look at the machine. First we will find out the minimum time, where the minimum time appears. So minimum time is 3. So minimum time, if it appears in machine. Now we'll check the machine. So here is machine 2. So that means job 2 will be processed at the end. So how we'll write? We'll write the sequence this way. So you will make a box, 1, 2, 3, 4, 5, 6, and so there are the 7 boxes that I have made. So that means this 3 minimum time appeared in machine 2. That means job 2 will be processed at the end. So job 2 I have put it last. So job 2 is done. So I've crossed the job 2. Then next minimum. Then I'll repeat this rules again and again. So next minimum is, I think it's 4. Next minimum is 4. So 4, where it appears, it is appearing in machine 1. That means job 7 will be processed at the beginning. So job 7 is processed will be at the beginning of the queue. So job 7 is done. Next again we will find out where does the minimum appear. Where does the minimum appear? Yes, next minimum I can see is 5. So 5 is job 1, and that appears in machine 2. So that means job 1 will be again processed at the end. So already last place is kept, already booked. So it is to be before that. So this is J1. Then again we will find out where is the minimum. Yes, the next minimum is 6. So J6 will be, and this 6 is appearing in machine 2. So job 6 will be put. So job 6 will be put here. Job 6 is here. Then again we'll see where is the, yes, what is the minimum. Minimum value is 7. Minimum value is 7. So again 7 is in machine 2. So this is job 3 is here. Again what you can see is next minimum is 8. That is also in machine 2. So this is J5. And what is left with, we are left with J4. So that will be J4. So hence we get the sequence, the optimum sequences: J7, J4, J5, J3, J6, J1 and J2. Now here one thing is to be discussed, that in case of a tie, if the minimum value appears for 2 different jobs, then what will happen? If the minimum value appears for two different jobs, then what will happen? Now we have to check if the minimum value appears for two different jobs and for two different machines. If it is for two different machines, then there is no problem. Like if, say, suppose take an example. So suppose if J3 is minimum as 6 and machine 1, and J7 has minimum again 6 for machine 2. So that means both of them are minimum, 6, both of them are minimum, but as they are appearing in two different machines, accordingly, so J7 will be going at the end of the queue and J3 will be going at the beginning of the queue simultaneously. So if this two minimum value appears in two different machines, then there is no problem. We will be doing according to the rules. But if it appears for same machine, then there is a problem. Then there will be a little difficulty. Say, take this example. Say if it is both the cases J3 and J7, both of them are 6, and here it is 9 and it is 11. Then both J3 and J7 will go, because it is appearing in machine 1, both J3 and J7 will go at the beginning of the queue. But whether the sequence will be J3 J7 or J7 J3, that is the question. For that, that can be decided by looking at the values at the machine 2. So here for J3, machine 2 value is 11 and J7, the machine 2 value is 9. As we know that if minimum value in machine 2, it goes to the back. And so mind that both J3 and J7 will go according to machine 1. Value of machine 1, they will go in front of the queue, but their sequence will be either J3 J7 or J7 J3, but the correct sequence will be J3 and J7. Correct sequence will be J3 and J7 and not J7 J3, because J3 and J7, in case of J7, this in machine 2 the value of J7 is 9 and machine 2 the value of J3 is 11. So in machine 2, if it is less, it goes at the back. That is the simple rule that we are following. So since J7 has the minimum comparatively smaller value than J3, so J7 will be processed back later. So correct sequence will be J3 and J7. Now if it happens the other way, if J3 J7, so say take an example J5 and J8. Take an example J5 and J8, they are machine 1 and machine 2, values are like 5 and 5 and 9 and 12. So in this case the tie appears for and minimum value appears for both J5 and J2, whose minimum value is 5. Both of them, their minimum value is 5, and both of them are appearing in machine 2. As they are appearing machine 2, they will be processed at the end of the queue. They will be processed. Both of them will go at the end of the queue. But whether the sequence will be J5 J8 or the sequence will be J8 J5, that is the question. That can be decided by the values they are having in machine 1. So in this case, the value for J5, the value in machine 1 is 9, and J8, the value is machine 1 is 12. Now as we know, in machine 1, if the value is less, it will go in the front. So that means in this case the correct sequence will be J5 J8 and not J8 J5. In this case, this will be J5 and J8. So J will be processed at the end and J8 will be processed at the just before that. So So if both the values are if the tie happens in case of machine 1, both the jobs will go at the front, but the sequence will be decided by their values in machine 2. And similarly, if the minimum value appears in machine 2, both the jobs will go at the back and their sequence will be obtained by their values in machine 1. Okay. Okay, now we'll calculate the time, and that is the ultimate job of after finding the optimum sequence. So after finding the optimum sequence, we have to find the time required to complete the activities. And here one thing is to be noted, that although you can find in different books that you can find that there is an idle time in machine 1, but I do not think there is any idle time in machine 1, because whatever be the sequence, all the jobs are to be completed in machine 1 first. So the person who's doing that job, after he finishes all the jobs, he can go and leave, so he does not have any idle time. But for the person who's working in machine 2, he can only complete his job if he is having the job in his hand, in his or her hand. So unless the job comes to him, he has to wait. So there is some idle time, and if the previous job is finished and still the next job has not come to his hand, so that means he is sitting in idle. So, but as a worker, he will be getting the pay for all the time that he is staying for his job. So as we know, in factories and in different places, the workers are paid according to the time spent, that according to the after the scheduled hours, if they are working overtime, so how much time they are spending in their work. So also you have studied in work study and method study that how much time they are working, so their efficiency is also being calculated, the time of wastage, the wastage time, and other things that have been calculated during this during the job that they are doing. So how much time they are wasting, how much time they are actually doing their job. So those are the important aspects of finding the efficiency and finding the means utilization of the resources. So here in case of machine 2, there is some idle time. So here our objective is to calculate the idle time in machine 2, and as we have already said that idle time in machine 2, we have to minimize the idle time in machine 2. So we'll make this is a table for calculation that we'll be doing. So what we do, we'll write down the sequence, then the time calculation for machine 1, then time calculation for machine 2, and then idle time in machine 2. And now we'll write down the sequence that we have already obtained previously, that is the optimum sequence that we have already obtained. So accordingly we have written the sequence as J7, then first job is to be processed J7, then it is J4, then J5, J3, J6, J1 and J2. So we have written the sequence. Then in machine 1 we'll calculate. So for calculation of time, we will just see. Yes. So we have written in and out. So when is the in time in machine 1 and when is the out time. So all the activities that start, starting time is 0. Then job 7 takes 4 hours or 4 days or 4 units of time. So 0 plus 4, out time is in time plus that job time. So 0 plus 4 is 4. The next job will start immediately, that it will start from 4. So J4 takes 11 units of time in machine 1. So 4 plus 11 is 15. The next job will start immediately, J5, 15 plus J5 takes 10 units of time. So 15 plus 10 is 25. So 25, J3 is also 10, 25 plus 10 is 35, J6 35, 35 plus 14. 35 plus 14 is 49. Next job is J1, 49. J1 plus 49 plus 8 is 57. And finally J2 is 57. 57 plus 6. 57 plus 6 is 57 plus 6 is 63. So in machine 1 all the jobs are completed in 63, but what about machine 2? As we have said, unless the job is done in machine 1 it cannot go to machine 2. So that means the first job that will be starting in machine 2 is J7, and it is only available after it is finished in machine 1. So that means it will start the in time for the first job, that is J7, in machine 2 is 4 units, because the job is completed in machine 1 and then it goes to machine 2. So in time is machine in time in machine 2 is 4 units, and J7 takes 7 units of time in machine 2. So 7 plus 4 is 11. Yes. Now out time is 11, but when the next job will start? So we will compare this out time with next job out time in machine 2. But J4 is not yet completed in machine 1. So machine 2, the person who is working in machine 2, he has to wait. He can't do unless it is completed in machine. J4 is completed in machine 1. So we'll compare this out time of the current job in machine 2 and the out time of the next job in machine 1. And whatever is maximum, that will come in time as the in time of the next job in machine 2. So here it will be 15 and not 11. Unless this is completed, it cannot come to this machine. So 15. Now J4 takes 12 units of time in machine 2. So 15 plus 12 is 27. So 27. Here it is next job. J5 is the next job, which is already completed by the time this job is completed. So next job is 25. It is already completed. So we'll compare 25 with 27. Maximum is 27. So we'll write 27 here. So 27. J5 takes 8 units of time in machine 2. So 27 plus 8 is 35. So this 35, this is 35. This is also 35. That means it can start immediately. So next job starts at 35. J3 takes 7 units of time in machine 2. So 35 plus 7 is 42. Again J6 is not yet completed. So the person who is working in machine 2 has to wait. So we'll compare 42 with 49 and the maximum value comes. So here it will be 49. So J6 takes how much time? J6 takes 6 units time. So 49 plus 6 is 55. 49 plus 6 is 55. Again 55 and 57 we will compare, and the maximum is 57 will come over here. So 57 will be here. And J1 takes 5 units of time. So J1 takes 5 units of time. So 57 plus 5 is 62. 62. So 57 plus 5 is 62. But again this is 63. So 63 will be here. And 63 and J2 is 3. 63 plus 3 is 66. So that means all the jobs are completed in machine 2 by 66. But what about the idle time? Yes, for in machine 2 the first job starts at 4. So first, in case of the first job, that idle time is 4 units. Now the first job is completed in 11. First job's out time was 11, but the second job's in time was 15, so there is a difference. So we'll always find out the idle time from the next job's in time to the previous job's out time, subtracting the next job's in time to the previous job's out time. That is 15 minus 11, that is 4 units also again. Here 27 minus 27 is 0, 35 minus 35 is also 0, 49 and 42, so in time is 49, in time is 49, out time previous job is 42, so the difference is 7 units. Then 57 minus 55 is 2 units, and finally 63 minus 62 is 1 unit. So 1 unit. So hence total time required to complete all the jobs in both machines was, this is the value, final value is 66 units, and minimum idle time is time in machine 2 is, you just add 4 plus 4 is 8, 8 plus 7 is 15, 16 17 and 1 18, that is 7 plus 10 and plus 8 is 18 units, and that completes the problem.